The idea of the unit circle is that if we inscribe a right triangle inside of it, its hypotenuse has a length of 1, and therefore we see that sine of the angle is going to be the opposite side divided by the hypotenuse, which is just the y value of this point divided by the hypotenuse, which is 1, which is just the y value. And looking at this in a similar way for cosine, we see that cosine is adjacent over hypotenuse. Well, the adjacent side is just the x value of this point, and the hypotenuse again is 1. That gives us x over 1, or x. And so what we see is that the point on the unit circle that has the coordinates x, y actually is going to be cosine of the angle and sine of the angle. And so remembering the sine and cosine of the special angles around the unit circle is really just a matter of finding patterns to be able to remember the xy coordinates of the points that are formed by the triangle. So let's look at the unit circle with the angles and coordinates superimposed on it. So as you can see, at this particular angle, 30 degrees, we see that the x coordinate of this point is the cosine of 30 degrees, which is approximately 0.866. It's exactly the square root of 3 over 2. And we can see that the y coordinate of this point is the height of the triangle, which is 1/2. When the angle is 45 degrees, we know that the x and the y values, the two legs of the 45, 45, 90 triangle, are going to be the same length. And that length happens to be about 0.707, which is exactly square root of 2 over 2 for both the x and the y, or the cosine and the sine. At 60 degrees, we have the same situation that we have at 30 degrees because this is a 30-degree angle. And so we would expect then that since this triangle is just the 30-degree triangle flipped x and y, that we would have the same values here except exchanged. In other words, cosine of 60 degrees is 1/2, sine of 60 degrees is square root of 3 over 2. And this is one of the patterns that will allow us to recreate the unit circle very quickly. And here I've highlighted the quadrantal angles, 0 degrees, 90, 180, 270, and then back to 360 or 0. And just to point out that those being on the x and the y axis would have coordinates involving 0 and 1 or -1. Now this view shows you the angles converted to radians, and that is going to be the way that we'll be working. So it's also important to understand how to convert from degrees to radians, if not to actually memorize the radian angles as you go around the unit circle. One last thing I want to point out is that the idea of x and y on the triangle coordinating with cosine and sine actually works all the way around the circle, because as you can see here, my x coordinate for this particular triangle is a negative number, and my y coordinate is also a negative number. And you can see that all of the coordinates along here, which would be cosine and sine, cosine and sine, cosine and sine, will all be negative numbers. So the sine pretty much takes care of itself. Okay, so enough about why we have the unit circle. Let's talk about how to draw it. So I'm going to just start with drawing two axes, and you can see artistry is not a requirement. And then I'm going to put a circle on here. Okay, now we know that the coordinates at these points are going to be 1, 0. This is going to be 0, 1. This will be -1, 0. And here we will have 0, -1. Now let's start in the first quadrant. We're going to go ahead and put in our 3 lines for the 3 angles that we have, and we know this is 30, 45, and 60 degrees. Now we're going to want to be able to remember how to get the radian measure for these. So here's what I'm going to suggest. This of course is 0. This is your starting point right here. your angles will go positive this way. If I go all the way around the circle, I will have 2 pi radians, because a radian is the angle whose arc length is 1 radius. And since the circumference is 2 pi times radiuses, we know that there's 2 pi radians in the circle. Well, if one time around the circle is 2 pi, then halfway around the circle over here is going to be 1 pi. And so if halfway around is 1 pi, then a quarter of the way will be a half a pi, or pi over 2. And now let's look at these other angles here. We know that 45 degrees should be half of this, so this is going to be pi over 4. 30 degrees, how can I get 30 degrees from 180? Well, I would divide 180 by 6 to get 30. I can do the same by dividing pi by 6, and that gives me pi over 6 radians. And in the same way, I can say how much can I divide 180 by to get 60 degrees, and that turns out to be 3, so this is pi over 3. So that gives us our angles. Okay, now in order to get the coordinates, this is the trick that I'm going to show to you. I'm going to set up coordinates over here with just the parentheses and a comma in between. And I'm going to start with the 0 in the x position here, and I'm going to go this way. I'm going to go 0, 1, 2, 3, and I'm going to go 0, 1, 2, 3. I'm then going to put each of those over 2, and then I'm going to square root the tops. Now, whether you square root the 1 or not doesn't really matter, because square root of 1 is still 1, but it follows the pattern in any case. And those are your coordinates. Now, those are the coordinates only for these 3 angles, and of course we've got these coordinates as well. How do we get the rest of the circle? Well, first of all, for purposes of taking an exam, I would say draw this much of the unit circle and just do the rest as you need it. Don't take the time to try to draw the whole thing at once. But if you do need some other angles, here's what you can keep in mind. Let's look at this point right here. If I reflect this point across the y-axis, I'm going to get the same angle here as I have here. In other words, this angle is going to be 30 degrees more than 90, or 120 degrees. Now, what's important here is that the y value has not changed, and so I know that my y coordinate is just square root of 3 over 2. My x coordinate is the same distance, because these are both the same angles and basically the same triangles, right? So this distance is the same as this distance, it's just that now this is going to be negative 1/2. And you can also see that because in quadrant 2 over here, our x values are negative and our y values are positive. And so continuing on around the circle, we're going to go ahead and be able to put negative square root of 2 over 2, comma, square root of 2 over 2, and negative square root of 3 over 2, comma, 1/2 for those angles right there. And so continuing that pattern of reflection, we end up with all of the coordinates around the circle. And just to point out again, quadrant 2 we already talked about, negative x, positive y. Quadrant 3, both are negative. And then quadrant 4, positive x and negative y. Now, I apologize for the poor quality of the handwriting here, so I'll put up a good unit circle here. Okay, so we're back to this view, and so this shows us the radian angles for the unit circle along with our coordinates. So how do we get all of these fractional radian angles here? These are a little bit difficult because there's not a really simple clear pattern like the 1, 2, 3 pattern that we saw before. So there's several ways that you can think about doing this, but one thing I want to point out to you is that let's look at this guy right here, pi over 6. If I go straight across, I see I also have divided by 6. I have a pi over 6. If I go straight down from there, I have a pi over 6, and straight across pi over 6. From here I've got pi over 4, pi over 4, pi over 4, pi over 4, and for these angles, pi over 3, pi over 3, pi over 3, and pi over 3. And I guess we don't want to forget about pi over 2, 2 pi over 2, and 3 pi over 2. So to get the numbers, the rest of the numbers for the numerators here, if you can remember that here at pi, this could be 2 pi over 2, this could be 3 pi over 3, 4 pi over 4, or 5 pi, I'm sorry, 6 pi over 6. Then we can make some decisions going forward from here. In other words, if I needed 7 pi over 6, if I know that this is 6 pi over 6, then it's going to be the next pi over 6, which would be 7. Another way you can do this is to just count around, and you have to be fairly good at fractions to do this, but if this is pi over 6, this is 2 pi over 6, which of course is pi over 3. This is 3 pi over 6, which is half a pi, pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6, 6 pi over 6, 7, 8, 9, and so on. And you can do the same with the pi over 4. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and so on. So that's one way to remember how to get the angles from around the circle. Otherwise, you'll just have to find those particular angles if a problem comes up. You should already have the coordinates either drawn, or you can get them very simply from the reflections from the ones that you drew in the first quadrant. Okay, so let's just review the process here real quickly. Step 1, draw your x and y axes and then a circle. Next, label the coordinates at the quadrantal angles 0 degrees, 90, 180, and 270. Draw the 3 rays that represent the special angles of 30, 45, and 60 degrees. Label the radian measures from 0 to pi over 2. So you can remember the angles in between 0 and pi over 2 by remembering that 180 degrees is pi radians, and then just divide by the numbers that you need to get those angles. Draw your blank coordinate pairs at those angles, just the parentheses and the comma. Starting with the 0 and the x-coordinate position at pi over 2, go around labeling 0, 1, 2, and 3 in the x positions of your blank coordinates. Do the same thing starting at 0 for the y coordinates. Put all the x and y coordinates over 2. Square root the numerators. Remember that the square root of 1 is still 1. Reflect the coordinate pairs as you need them, keeping in mind that the different quadrants will have x and y positive or negative depending on their rules. Reflect the pi and the denominators of the angles as you need them. And fill in the angle numerators as you need them.